Hi everybody. Guess what? We finally made it out of the skeletal system. We've finished up with the joints and we are to muscles. And this first little unit regarding muscles is going to be pretty short, comparatively speaking, and it's the intro, but it's all about like the cells themselves, the tissues, before we get to the next units and deal with specific muscle groups and where they are in the body and all those kinds of things. So essentially we're talking about muscle tissue and muscle tissue or muscle cells in particular, because remember that cells make up tissues, and so the cells in the muscle tissues that we're going to talk about are more like muscle fibers. They are long, they are elastic in a lot of ways. They are very shapeable, and so they can contract and flex and extend and stretch and all those different kinds of things. So a little bit different than, obviously than a skin cell, or clearly different than a bone cell. And this is important because they are, as far as function goes, they need to be able to move and stretch and contract and those things. Okay, so there are three types of muscle tissue, and we will talk about all three types when we get into the actual muscles, like your leg muscle or your arms or whatever. We will be dealing with the first type that I'm going to talk about now, which is the skeletal muscle tissue, excuse me. And so these are the muscles that attach to and cover the skeleton. And so these are the ones that you probably are the most aware of, because these are the ones that you can flex, that you can, as you work out, can see get bigger. These are the ones that you have more control over. And so as far as unique characteristics, they are the longest muscle cell types. Remember, they're all kind of long, kind of that fiber shape, and they have striations. And I know this, you'd have to probably put your face super close to the computer to see that, but there are stripes on this picture that are running this way, and so they're super teeny tiny, kind of hard to see, but those are the striations. Now, the more I'm looking at it now, the more I can see them. Maybe my eyes are tricking me, but that's what, when they talk about stripes, it's not the horizontal stripes that are on there. These are cells that can be controlled voluntarily, or tissues that can be controlled voluntarily. So when you think about it, you can flex your bicep, and no, some of them, they're not necessarily, they're never, anyway, scratch that. But so they are controlled voluntarily. They also have multiple nuclei per cell. That's because they are doing a lot. They're needing a lot of ATP for energy, so they have to have things going on. They need proteins that help them, build back up and do all those different things. And so lots going on in the cell, and that requires these multiple nuclei. Okay, so there's the picture of that one. We will do a day in class where we look at the different slides, so you see some of the histology. But there you go. That's the muscle cell, skeletal muscle tissue. Okay, so now cardiac muscle tissue is only found in the heart, hence the cardiac part. And notice, just looking at that top picture on that page, it is similar. You have the horizontal kind of stripes on there, and it is also striated. Again, you have to look really close to see those stripes. And these are involuntary, which means that these are not muscle cells that you think about and control, because your heart needs to beat 24/7, otherwise you're not alive anymore. And so this is an involuntary muscle tissue, and so it makes up the walls of the heart. When we get to the cardiovascular system and talk a little bit more about the heart in general, we'll, I've already covered this, but the heart itself is a muscle. And so very, very special, very important type of muscle in there. And it has, like I said, some characteristics, the striations, the kind of the appearance of the skeletal muscle, but different mainly because of the involuntary nature of those cells. Okay, then smooth muscle tissue. These are found in the walls of hollow visceral organs, which is basically like your stomach or your bladder, your respiratory passages, anything that is open, anything that needs to move or contract in any way. These contain or are made of smooth muscle. And so notice the picture is a little bit different. You don't have the striations, first of all, which again, even though you can't see them in that top picture, it's one of the main reasons that the bottom picture looks different. And so, so it's not striated. You don't have those stripes because the contractions and the movements of these muscles are a little bit different than the cardiac muscle and the skeletal muscle, which are simply contracting and then expanding. The smooth muscle has kind of multiple layers of contraction and movement, and so so that is the big difference there. These also are involuntary, and which means you have, again, no control over it. You don't tell your stomach when to contract and kind of mush up your food. You don't, even though you obviously know how to control your bladder, you don't really control the contraction of it when you go to the bathroom. That's a kind of a different process. But so anyway, oh, that's lovely to talk about, isn't it? Anyway, so these are the three types, so skeletal, cardiac, and smooth muscle tissue. Okay, so now functions of all muscles. They're producing movement, and so obviously that is a big part of your skeletal muscle tissue because it's moving your body around. But again, the movement of food down your esophagus, the movement of food, digested materials through your intestines, that's movement still. Your heart is moving, it's contracting itself in order to move blood. Your muscles help to maintain your posture. So I try and sit up straighter here. They stabilize your joints. We've already talked about the fact that muscle tone is very important as far as joint stability goes. And then the last one that we may not think about that much is they generate heat. Your core, your chest, your abdomen, that part of your body is very reliant on a fairly narrow temperature range for every cell and every body part to function well. And so your muscles, as they contract and your heart beats and your stomach contracts and all those different things, that movement, remember, energy, you can't ever get rid of it. You can just have it change form. Some of that movement is converted into heat. It helps keep you warm. Okay, now muscle characteristics. There are 4 listed here. The excitability, irritability. This is hugely important because it means that your muscle cells can receive and respond to chemical signals, to a stimulus. Chemically, those are neurotransmitters, hormones that your body produces and sends out, or different changes in pH. All of those are signals to your cells, to your muscle cells, okay, contract or move or do whatever. And then the next characteristic, contractibility. So they have the ability to shorten forcibly when stimulated. So this is, like a flex. Extensibility, they have the ability to be stretched back out or extended. And so again, it goes back to the muscle fibers and just their physical characteristics. And then finally, elasticity. So that means they can go back to their original shape or their resting length after being stimulated, after being moved for some reason. Okay, so now this first type of skeletal muscle, so a muscle itself, the anatomy of it, and there are 5 main parts that I want to talk about. They're kind of parts and subparts, or kind of different levels. And the picture on this page I think is really good as far as getting kind of helping you see what you need to see. So first off, the endomysium, this is a sheath, and all of the ones that I have stars next to, so numbers 1, 3, and 5, those are coverings that are around the muscle fibers, or the different parts. And so They are just kind of support there. Okay, so anyway, the endomycium is a sheath or a layer of connective tissue that is around specific or groups of muscle fibers. And so in that picture, here is the endomycium. They have a kind of, I don't know necessarily how that's how I would label it, but it is kind of the white part around and in between those pink dots. Those are the cross section of a muscle fiber. And so then the fascicles, which is back over here, that is the bundle of these ensheathed fibers. So the endomycium contains everything and wraps it, makes it into a vasicle. Then you have the perimycium, and this is a sheath of collagen surrounding fibers. And so now this goes around a bundle of fascicles. And so that is, here's the perimycium up here, and it then makes a grouping. And then the epimycium is a bundle, like I said, that is a bundle of those fascicles. And then finally you have what is called the deep fascia, and this is the fibrous connective tissue, and it actually wraps around the whole muscle and makes it one huge group. So those are the different parts. They also, like I said, they're stretchy. They are places for blood vessels, nerve fibers, all those different things to get in and out of the muscle cells or muscle tissue. Okay, now muscle metabolism. So your cells, every single cell, but including your muscle cells, rely on ATP. Adenosine triphosphate, that is the energy molecule for all cells. We talked about it when you guys were in biology, back when you were sophomores, and it's the energy molecule for cells. And so for muscle cells, they need ATP continuously. And there are three main ways that your muscle cells will regenerate ATP. ATP can't be stored, it's too unstable, but it is very easy to make from ADP, which is a precursor, and phosphate. And so to continuously make this ATP, your body can use creatine phosphate, and this is a high energy molecule. Its energy can be used to put some ATP together, and then you get that energy burst. But this is used for kind of short bursts of activity, kind of the initial contraction of your muscles to start with. And so if you are a weightlifter, you might use this as a supplement. It helps you to do kind of the quick kind of jerky movements with weightlifting, but it just gives you that kind of initial burst. Aerobic respiration, that's the main one we focused on when you guys were in biology, is a series of reactions, and it uses oxygen, which is why you're breathing, and glucose, which is comes from the foods that you eat, and this produces ATP. Big long series of steps, and this is what your cells are doing right now, most likely. This is when the cells are just kind of doing light work. You know, you're not running a sprint or anything like that. You're writing notes. And so you have plenty of oxygen, you're breathing normally. And so most of the time your cells and your muscle cells will use aerobic respiration. Then finally, anaerobic respiration. This is ATP without oxygen. This is when you've been running for a while and you're out of breath, essentially. Your body can go through anaerobic respiration. The downside to that for muscle cells is that lactic acid is a product. There's some debate. Some people say that can be what makes your muscles feel sore after you work out. Other people say it doesn't. But anyway, it doesn't give you as much energy, but it gives you enough to keep going until you catch your breath. Okay, so now the energy systems used during sports. So if you are weightlifting, like I said, kind of quick movements that require a lot of your muscles, diving, sprinting, like in gymnastics, like the vault, that kind of thing. This will use stored ATP. I already said you can't store it, but you can get to it quick, and that creatine phosphate. So those are quick, short activities. things like tennis, soccer, basketball, 100-meter swim. These are anaerobic respiration, usually because you get out of breath fast. If you've ever watched, a tennis match or soccer game, basketball, they, run these short sprints, and then they, everybody almost immediately, like as soon as you take a breath and stop, you can tell they're breathing really hard. The swimming, of course, is a little harder to see if they're breathing or not, but boy, when they finish that 100 meters, you can see them really gasping. And so, again, it's your body does enough in that situation to keep on going. Now, if you are in shape, which I am not, but if you were in shape and you do a long-term kind of steady paced thing, like run a marathon, or if you're a jogger, your body conditions itself, and you can go back to aerobic respiration where your body is ready for an increase in activity, but will still continue to make the right amount of ATP. So anyway, so those are kind of what your body does in certain situations. Okay, so now smooth muscle. This is the muscle that, like we said, lines your stomach and your respiratory passages. I didn't put it on there, but your esophagus as well. But anyway, these are made of fibers that look like little kind of spindle-shaped cells with just one nucleus. So this is a picture down here of one, and you do have connective tissues between. That's the endomysium, and that's where the blood vessels are, the nerves, all those things. So you don't have the kind of building up of different groupings to make the muscle like you saw in the skeletal muscle, but you have some of the same parts. In most organs, and this is where kind of that difference comes in, the muscle fibers are arranged in sheets. And the two layers will run, like opposite of each other. I don't know where to put my hands. Opposite of each other. So when they contract, or when they are working, they work kind of in opposite directions. So you have a complete contraction. You have a different than just a flexing of the muscle. You have a more surrounding motion, and this contraction is a lot of times called peristalsis. We relate that a lot of times to your esophagus because it kind of pushes food down in kind of bundles, and so that's kind of the shape, I guess you would say, of the contraction of smooth muscle. Okay, so last type of muscle is cardiac muscle. So the heart muscle, of course. So there's a picture of a heart. Remember, it is striated, so it has the stripes, which you can see a little more easily in this drawing. And one or two large nuclei. Again, it's a cell that needs to always be working, and so you have to have lots of direction in there. These cells are short, kind of squatty, fat cells, kind of branched. I know it looks like there's a bunch of space between them in that picture. It's not. They're all kind of smushed together, but the cells themselves are a little differently shaped. They are always needing energy, so you have lots of mitochondria, and they're very large, and they make up a pretty big, take up a lot of space within the cell. And as far as your heart goes, what it needs oxygen because it relies completely on aerobic respiration. And it's one of the things that your body kind of does automatically. Is even if you are sprinting, or you're playing basketball, or you're doing whatever, the amount of oxygen that you're taking in won't be enough for your whole body because of how hard your muscles are working, but your heart and your brain will get kind of first priority on the oxygen, so they can keep on going through aerobic respiration. That's the most efficient, or the best way for cells to make that ATP. Your heart's a big deal, so that's why it gets kind of first priority. If necessary, though, there are multiple pathways that, chemistry-wise, the metabolic pathways that your cardiac muscle cells can follow, similar to cellular respiration, in order to get to ATP, which is the kind of the end point there. Okay, so like I said, pretty short, kind of introductory unit to the rest of the muscles. as always, ask me questions. I know you will. And you can use this to get ahead, to catch up, to do whatever. So let me know if you have questions. Bye, guys.